Hello and welcome back to another tricky A-level further maths exam question. So this is question 2 or day 2, whichever way you prefer to think of that, if you're doing this as a daily exam revision series. But either way, let's not waste any time then, and let's just get started here with question 2. Now, as we can see then for question 2 here, very light on the detail. What we're given here is A and B are 2 by 2 matrices. And all we want to do here then is prove that the determinant of the product here, AB, is equal to the determinant of A times the determinant of B. Now, this is just one of those standard results here that you should be aware of anyway. But how do we prove this? So that's what we're going to tackle here with this question. Now, to begin with here, all I'm going to do then is just take two general 2 by 2 matrices. So I'm just going to let A here. So let A equal to the following 2 by 2 matrix. So A, B, C, D, like so. And we'll let B here. So let B equal to, so just following on alphabetically here, we get E, F, G, and H. Okay? So to begin with here, let's just find the determinant of A and the determinant of B to begin with. So in that case then, the determinant of A here, so det A, is equal to, so this should be really straightforward, right? It's just going to be AD minus BC. So AD minus BC. And then we just repeat this process here for the determinant of B. Again, nice and straightforward here. In that case, then det B is just simply, it's just going to be EH minus FG, right? So EH minus FG. Perfect. Okay. So we've got the determinant of A, the determinant of B. Now, let's just express this here as a product, as the right-hand side demonstrates. So, in that case then, det A times det B, that is equal to, so it's going to be AD minus BC times this here, EH minus FG, right? So, I get AD minus BC times by this here, so EH minus FG, like so. And if we just expand this here, then what would we actually get? So obviously just take your time here. There's nothing mathematically too challenging. Just make sure obviously that you take time with the actual multiplication and make sure that you don't get the letters kind of incorrect here once you multiply out. So starting off then, we've got AD times EH. So we get AD, so AD, EH. I've then got AD times minus FG. So I get minus then AD, FG. I've then got minus BC times EH. So again, we get minus here. So I get minus BC, EH. And then finally here, minus BC times minus FG. So again, just be very, very careful with your signs here. What we should get here then is plus. So I get plus BC, FG. Perfect. Okay. Now, clearly, this is the result then that we want now for the determinant of the product here, AB. So this is what we're aiming for. So to begin with here then, let's just find the product of AB, right? We need this matrix here, AB. So AB then is the product of these two matrices here. So that would be A, B, C, D times by this matrix here. So EF, GH. So E, F, G, H. Perfect. Okay. So what would we get here? Well, clearly the result will be a 2 by 2 matrix, right? That shouldn't be surprising to anyone. So this row times this column, I get AE plus BG. AE plus BG. I've got AB times FH. That would be AF. So AF plus BH. So AF plus BH. Perfect. I've then got this row times by this column here. That would be CE plus DG. So CE plus DG. And then finally, this row here times by this column here. So what I get then is CF plus DH. Perfect. Okay. And up to now, everything looks good. So what I need to do here is just find the determinant then of this 2 by 2 matrix. And again, this should be pretty straightforward. So if we do this underneath then, the determinant here, so det of AB is equal to, so I've got this element here times by this element here, minus then this element here times by this element here. This is all very straightforward and elementary, right? But let's just go through the full process. So we've got AE plus BG times by CF plus DH. So CF plus DH minus then this element here. So that is CE plus DG times by this element here, which is AF plus BH, right? So, close that bracket and then times it by this one here, AF plus BH. There we go. Perfect. Close that bracket as well. So let me just get rid of that kind of dot there, just because it's annoying me. There we go. I'm happy now. Right, so let's just keep going here. So clearly what I need to do here then is just find both of these products, right, and just simplify. And hopefully once we simplify then, we should get this result here, okay? So AE times CF, I get AECF. So AECF. I've then got AE times DH, so I get AEDH. I've got plus BG times CF, so BGCF. And then finally BG times DH, I get plus BG DH. Perfect, that's the first four results here. We now subtract this product here, right? So again, all I need to do is just expand these double brackets, and hopefully some of the elements should cancel and we should get left with the equivalent to this here, right? So each term here will be negative because it's minus this product here. So I've got CE times AF. So I get minus CEAF. Perfect. I've then got CE times BH. So I'm going to get minus CEBH. I then get DG times AF. And again, we'll take the negative of that. So minus DG AF. And then finally here, DG times BH. So again, this will be negative. So minus DG BH. Perfect. So the only way that you can kind of really trip up here is just getting confused with the letters and what will actually cancel. So it becomes more of an English test than an actual maths test, right? So let's just be careful here. So I've got AECF. I've got minus CEAF. So obviously the letters are in a different order, but that doesn't matter. They will still cancel. So this here cancels with this here. Perfect. What else do we have then? So in this result here, we've got an ADEH. I've got an AEDH here. So that's fine. Again, the order's different, but it really doesn't matter. So I'm going to give that a tick here for now, just so I can see that that's correct. I've got a BGCF here, and I've got a BCFG here. So that's fine. They will be the same as well. Again, the order's different, but it doesn't matter. I'm going to give it a tick here so I know that that's correct. I've got a BGDH here, and I don't have one here, right? So BCEH, that one's already matched up to that. So this needs to cancel. And that will cancel with this term here, right? DGBH. Again, the letters are in a different order, but honestly, it doesn't matter. They just cancel like so. What else do we have here? So I've got minus CEBH, and I've got the same here, right? So BCEH. Perfect. Again, the order's different, but we're not bothered about that. Give it a tick. And then finally, minus DGAF. That matches up with this here. So ADFG. Perfect. So what I'll do here then is just write that in the same order, just so you can see how that matches up. So this is ADEH. Perfect. That's this term here. I've got BGCF. So that matched up to this one here, BCFG, right? So plus BCFG. Perfect. I'm just taking my time here just so I don't make any silly mistakes. BCFG. We had this one here, so minus CEBH. So apologies, I'm losing my voice, by the way, but we're nearly there. So minus CEBH, that is this one here. So minus BCEH. Perfect. And then what am I missing? I'm missing this one here, right? So minus ADFG. So minus ADFG. Perfect. And just notice here then, this is the same as the determinant of A times the determinant of B. That's equal to det A times det B as required. And therefore then our proof is complete. Beautiful. Okay. And there we have it then. So hopefully this demonstration, this explanation here has helped illustrate how to tackle and approach a question such as this one. Like I said, this here, this result of the determinant of AB being equal to det A, det B, that's a standard result for 2x2 matrices here. Off the top of my head, I think it extends to large matrices. So this is just a result you should be familiar with anyway. So, you know, are you going to get asked to prove this in an exam? Maybe not, but it's challenging. It's testing those more able students. And, you know, you're going on to do maths at uni. This is definitely the type of thing that you will be doing. So definitely good practice if you are going to go do maths at uni. But there we have it then. So that gives the solution here to day 2 or question 2 in our tricky A-level further maths exam series. As always, thank you for watching.